Detaching from external influences, unsupervised learning for Stoicism. Welcome back, dear friends. In our previous video, we mentioned self-mastery, detachment from external influences, and interconnectedness as the three dimensions around which we shall build a machine learning model for a Stoic life. In machine learning, a dimension describes the attributes characterizing the data used in a model. Our approach to self-mastery pushed us towards introspection for data collection. Since we had to navigate through our beliefs, values, and fears, we worked with labeled data building a supervised learning model. Today, we explore how to face external influences, which are often unknown, unpredictable, and uncontrollable. For this, we work with unlabeled data, stepping into unsupervised learning. External influences come from anywhere: our environment, interactions, or ingrained ideas from upbringing that subtly echo in our thoughts. Even though this data is unlabeled, we still engage in selection, removing noise, observing patterns, and preparing for surprises in feature importance. Stoics emphasize that events are neutral. Interpretation determines good or bad. In modern times, Ryan Holiday teaches us to treat obstacles as raw material for growth, focusing on process rather than outcome. Principal component analysis, PCA, mirrors this insight by revealing latent combinations of traits and events, prompting reflection. Which traits do I need to cultivate? How might this detour shift my path? What alternative routes exist to reach my goal? Unsupervised learning highlights two main families of algorithms for clustering and association. Clustering groups similar data points. In life, we can cluster challenges by domain and stakes. K-means, a popular algorithm asks, how many groups do you want? Large clusters, career opportunities providing stable income. Smaller clusters, innovative roles in untouched industries. The algorithm assigns each cluster a centroid and minimizes distances between points, and this center reflecting cohesion. The elbow method helps choose the number of clusters. As clusters increase, improvements level off, producing the elbow. Like Stoic wisdom, cluster selection considers distortion, are categories accurate? Inertia, are members of each group truly similar? Dunn index, how well separated are the clusters? The second family of algorithms in unsupervised learning is associations, which lead to the if-then relationships. If I transition to a new field, then I can withstand job-switching pressures. Algorithms like a priori use support, how often something occurs. Confidence, how often A leads to B. Lift, how much more likely A and B are to occur together than separately. Building resilience towards the unknown. Returning to supervised learning. The insights we developed around what external influences may affect us are comprehensive enough for us to categorize them as labeled data. We are therefore now returning to supervised learning. In feature selection, we prioritize triggers affecting judgment, impulses infiltrating decisions, ego distancing us from accountability, vapid stakes influencing our actions. Additional analyses include correlation, which features co-vary. Donald Robertson warns that thoughts create emotions, mastering them shapes life. Mutual information, how features impact one another. Naval Ravikant reminds us that solitude brings clarity. Just think of how many aha moments we reached through introspection, algorithm selection. Our goal of detaching from external influences can be achieved through both classification and regression. Classification is particularly beneficial to counteract our natural tendency towards reactivity. Is this worthy of my reaction? Since it's directed towards predictions, regression illustrates Nassim Nicholas Taleb's advice of how true wisdom comes from the ability to become comfortable with uncertainty. We'll start with defining a synthetic data set. Whether we opted for classification or regression, we'll start for the make. Classification or make regression functions with the following parameters. N samples covers scenarios testing gradual detachment. N features highlights the passions Stoics aim to free themselves from. N informative focuses on the passions we are most prone to, for example, delight rather than distress. Noise describes external influences we are indifferent to. Random state tests freedom from irrationality across areas. As a reminder, Stoics used irrationality to argue their opposition to distress, fear, and lust. Our response to external events can unfold alike the following algorithms. Support vector machines, SVMs. Events are neutral until judged, as per Donald Robertson. Polynomial regression. Voluntary exposure to discomfort builds resilience, as William B. Irvine teaches us. K-nearest neighbors, KNN. Searches for guidance from similar patterns or role models, as suggested by Massimo Pigliucci. Decision trees. Maps the influence of external events on our values. Random forests facilitate multiple perspectives for discernment. Neural networks mimics the brain, illustrating William B. Irvine's advice to find the Stoic strategy tailored to our personality. Generative adversarial networks, GAN, highlights the opportunity of creating an identity transcending external influences, just like Naval Ravikant reminds us that authenticity frees us from competition. Training and testing. Use train, test, split. Train on past experiences, test on new experiences. The recursive feature elimination, RFE, will help us remove ideas or values we manage to detach from, fitting the model.fit::learning from experience. Permutation feature importance evaluates, did this stressful prospect truly affect my life? Was it a blessing in disguise or a neutral step in the journey? Prediction. Now let's check how well we manage to detach from external influences. Epictetus teaches us to only be concerned of our reasoned choice, how we discern, respond, and adapt ourselves to external events. His words remind us of the evaluation metrics in machine learning. R squared, how much of my reaction is explainable? MSE highlights the weight of large errors. Are ordinary challenges still bothering me? May points out sensitivity to outliers. Are important influences still affecting me? Classification report gives performance metrics like precision and recall for anticipating reactions. K-fold cross-validation tests consistency. Are we truly practicing amor fati, accepting whatever happens without hope or fear? Fine-tuning. Stoic wisdom requires reflection and correction. Fine-tuning prevents superficial or rigid understanding. One of the four cardinal virtues, the phronesis, or the practical wisdom, leads towards an understanding of oneself and the world. The learning rate highlights the number of experiences needed for insight, whereas the epoch calls to the Stoic principle of allowing the full unfolding of an event before judging. Furthermore, did we properly label our training data? Machine learning models are often challenged by Gini impurity, which identifies mislabeled events, and entropy, which measures the level of disorder or uncertainty within the dataset. Gini impurity is found in exaggerating a once-in-a-lifetime opportunity. As for entropy, do we chase external validation instead of building self-esteem? As Massimo Pigliucci points out, wealth or status matter, but don't define worth. Therefore, the wisest thing we can do is to remain indifferent to them. Regression models reveal bias, oversimplification, and variance, hyperadaptability. Bias leads to underfitting, while variance to overfitting. An underfitting model is too rigid or generic, contradicting the Stoic principle which advises for progress rather than perfection. Rigid models blur opportunities for growth. An overfitting model is too reactive and adapts too much to specific situations. An ideal model has low bias and low variance. For that, we need regularization, which can be attained through the lasso and ridge methods. The lasso method keeps only the most important traits. The ridge method balances everything, even if imperfect. When do we use each? Let's say our flight has been canceled. The lasso directs energy to alternative routes instead of lashing out. The ridge manages logistics, turning downtime into productive or restorative action. Ensemble learning, resilience across life. Zeno of Citium, founder of the Stoic school of philosophy, advises us to live in agreement with nature. Modern Stoicism prevents spillover of emotional residue. Failed career deal? Don't let it affect self-esteem or relationships. This is where the ensemble learning kicks in by strengthening our results through the impact of more than one model. Bagging trains models independently, combine results through voting for classification or averaging for regression. The Stoics remind us that the only things within our control are our thoughts, opinions, decisions, and duties. Bagging would push us towards reflecting over how does an event influences my mindset, actions, and capacity for accountability. Boosting implies training models one after the other, fixing the errors produced by the previous ones. A combination of all models creates prediction. Let's think of the three types of act proposed by Epictetus: judgment, desire, and inclination. Errors in judgment gets us attributing a higher importance to certain issues. A poor evaluation of stakes gets us chasing goals which won't fulfill us. Investing our energy in suboptimal goals prevents us from identifying better opportunities. Boosting would help us properly discern an event, identify stakes worthy of our involvement, and highlight the best routes to follow. Stacking implies training different models and using their predictions as inputs for a final model. According to Stoics, we are endowed with all inner resources to achieve our goals. Stacking gets us combing all insights and external influence reveals, aspects to learn, strategies to follow, contingency plans to consider, and make the proper judgment towards how we should act. Stoicism is often misread as passivity and indifference to the blessings of life. In reality, it cultivates joy, kara, wish, bulisis, and caution, eulobeia. Becoming one with Stoic virtues is a journey of continuous evolution, captured in an ML model through the model.transform function, which mirrors the ongoing adjustment of habits, traits, and decisions in growth.